This presentation is going to go over the work equations sample problems that are in the science textbook. You can find these on page 128 in Chapter 5. The sample problem that the book shows us includes the following. You push a refrigerator with a force of 100 newtons. If you move the refrigerator a distance of 5 meters while you're pushing, how much work do you do? The equation for work is force times distance. The force that's being applied to the refrigerator is 100 newtons, and you're moving it a distance of 5 meters. Now, we know that work is applying a force on an object and then moving it in the same direction a certain amount of distance, and that would be what would happen here with this refrigerator. The force is equal to 100 newtons, so you put that in for F, and the distance is 5 meters. We take 100 times 5, you get 500, and we get newtons times meters. Now to clarify the units here, newtons times meters is equal to kilograms times meters per second squared times meters, or kilograms times meter squared over second squared, or a joule. So the value here would be equal to 500 joules. Let's look at practice problem 1. Practice problem 1 states, a couch is pushed with a force of 75 newtons and moves a distance of 5 meters across the floor. How much work is done in moving the couch? In this problem, we have a force of 75 newtons and we also have a distance that is equal to 5 meters. Using the work equation, we take the force times the distance. So it's 75 newtons times 5 meters. If you take a calculator and plug it in, 75 times 5, we find out it's 375. And our units would be joules. Let's take a look at the next problem. Problem 2 says a lawnmower is pushed with a force of 80 newtons. If 12,000 joules of work are used in mowing the lawn, what is the total distance the lawnmower was pushed? Now, this requires us to algebraically switch the equation. And let's see here. And we can derive for either work or find the answer for force or distance. So we're going to need to use distance is equal to work divided by force. So we take the work was 12,000 joules, which is equal to newtons times meters all over a distance of, force, sorry, of 80 newtons. We take the calculator, we type in 12,000 divided by 80 newtons to give us a distance of 150 meters. Now, newtons in the numerator and the denominator cancel out, just giving us the distance of 150 meters. Let's look at question 3. The brakes on a car do 240,000 joules of work in stopping a car. The car travels a distance of 50 meters while the brakes are being applied. What is the force the brakes exert on the car? So the equation that we're using here is going to have to find force. And the problem is we're being told that the amount of work being done is 240,000 joules. So force is equal to work divided by distance. So plug in the value for work, which is 240,000. And we're going to be using newtons per meter, or times meter, all over 50 meters. We can immediately see that meters in the numerator and denominator will cancel out. So our answer will be in newtons, which is good because that's force. And then we take our calculator, and we'll see that 240,000 newtons divided by 50 is equal to 4,800. So the force is 4,800 newtons. And the last problem. The force needed to lift an object is equal to in size to the gravitational force on the object. How much work is done in lifting an object of mass of 5 kilograms, a vertical distance of 2 meters? So this problem sort of has two steps. Now we are looking at how much work is being done by this object. It's got a force on it. We don't know what the force is because it's going to be equal to the gravitational force. So we know that weight due to gravity from the previous unit is 5 kilograms times the acceleration due to gravity, 9.8 meters per second squared, which is equal to 5 times 9.8, into the calculator, 49 newtons. So the force is 49 newtons. And we have to multiply that by the distance which the object was moved, which is 2 meters. We'll end up with Newton times meters as our units. We plug that into the calculator. 49 times 2. And we end up with 98. So 98 newtons times meters, or it's going to be 98 joules. That's the final answer.